Hi, it's Rich here from Past That Science. Going to have a look at an example today of how to determine the impedance of an AC circuit. The impedance, of course, is the combined effects of all the components in that AC circuit that are having an effect on the current. And in our example, we have a resistance that's going to have an effect on the current. Also, the inductor there has a reactance that's going to have an effect on the current. If you want to remind yourself of how to work out the inductive reactance, there's a previous video on that. So then the resistor, of course, it causes the current to remain in phase, and the higher the resistance, the less current you get, so that's clearly having an effect on the current. The inductive reactance, that causes the current to move out of phase, and it will also have an effect on the current. The impedance then being represented by that diagonal line. So for that purpose then, we can use Pythagoras theorem, or certainly a process similar to Pythagoras theorem that you did for your GCSE maths, where you said that h squared is a squared plus b squared. Now, since that we use different labels, we can say that z squared, that's the longest line, the hypotenuse, is r squared plus xl squared. We would like to condense that down a bit better to say that z is the square root of r squared plus xl squared for this example. So let's put the numbers in. So we're going to be using the formula z is the square root of r squared plus x squared. So r is 24, so 24 squared plus xl, which is 20 in this example, squared, all square rooted, put that into a calculator, comes out as 31.24 ohms. You need to remember that formula. Z is the square root of r squared plus x squared. Just to remind yourself though, x could be XL if your AC circuit has inductance and inductive reactance. It could be XC if it has capacitive and capacitive reactance, or XL minus XC if it has both. But Z is the square root of r squared plus x squared. That's science.